Okay, let's look at numbers 12 and 13. They're both proofs. Look, starting with number 12, use the diagram to prove that the measure of angle 1 is equal to the measure of angle 4. So what we're looking at is first what's given. Okay, what's given is that angle 2 and angle 3 are equal in measure, or they're congruent, and the measure of angle AXD is equal to the measure of angle AXC. Okay, so we can take the information that's given and we can write a proof, and it's pretty much done for us. We just have to figure out what goes in the blanks. So remember, we usually start with what's given. We know that the measure of angle AXD is equal to the measure of angle AXC. And remember, when you're planning a proof, sometimes you can see the whole solution or the whole proof before you get started, and sometimes you just need to state what's somewhat obvious and then look at that and build off of that. So let's just break down the measure of angle AXD. The measure of angle AXD is made up of angles the measures of angle, EXD and EXA, angles 1 and 2. So I can say that the measure of angle AXD is equal to the measure of angle 1 plus the measure of angle 2, or the measure of angle AXE plus the measure of angle DXE. Okay? And then I can say the measure of angle AXC is equal to the measure of angle AXB plus CXB, or the measure of angle 3 plus the measure of angle 4. Okay, what justifies both of these statements in the two-column proof is the angle addition postulate. We mentioned the angle addition postulate earlier. If two angles share a common vertex and a side, I can add the measures of the angles together, okay, to form the larger angle, to form the measure, or to determine the measure of the larger angle. All right, and from there, I'm going to state that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 and 4. All right, I'm using substitution. With this statement here, I'm substituting the measure of angle AXD with the measure of angle 1 plus 2, and with the measure of angle AXC, I'm substituting it with the measure of angle 3 plus the measure of angle 4. So now I have this statement, okay, and I see where I'm wanting to go with this. I'm going to be able to manipulate this statement to get what I want. The measure of angle 1 is equal to the measure of angle 4. So I'm going to throw my other given in. A lot of people miss the reason for the statement is given because they were used to seeing all the givens stated first in step 1. But we can mix our givens wherever we want in our proof. So I'm going to state that the measure of angle 2 is equal to the measure of angle 3. And when I do that, I can now say that the measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4. Okay, right here. And the reason I wanted to do that is because I recognize that if I can get this statement here, I have the same value on both sides of the equal sign. Okay, and I can use the subtraction property of equality. I can subtract the measure of angle 3 on both sides, and I'm left with the measure of angle 1 is equal to the measure of angle 4, because again, I've subtracted these values on both sides, and the subtraction property says that the measure of angle 1 is equal to the measure of angle 4. That's a true statement. All right, and then number 13, 3 steps of a proof are shown. Give the reasons for the last 2 steps. So they're starting with the fact that BC is equal to AB. They're showing that they're congruent. And we're just going to state that with the segment addition postulate, AB plus BC is equal to AC. Again, just kind of stating the obvious so that maybe I can come up with a plan. And when I look at these 2 statements and when I look at what I want to prove, I see that I can substitute BC with AB because BC and AB are equal. So I substitute BC with AB and I get this statement: AC is equal to AB plus AB. So segment addition postulate justifies step 2. Substitution property justifies step 3.